In this ANSYS tutorial video, we will be looking at Lab 3 question number 1. Before we get started, we first have to determine which units we're going to use throughout this question. And since everything is given to us in inches in this question, our best option would be to use the BIN column of the table of consistent units. So the only conversion we will have to do in this question is converting the 15 pounds per inch that's given to us here at the top and converting that into PSI. And to do that, we just have to divide it or multiply it by 1 over the thickness of the plate, and that will give us a value of 300 psi. Next, we can go ahead and determine the element type we are going to use throughout this question. And seeing as how we have a 2D object here with a thickness, we're going to create a solid model type and specify that it is a plane with thickness. Next, for material properties, we are going to enter in our elastic modulus and our Poisson's ratio that are given to us in the question. In terms of real constraints, all we have to do is enter in a thickness of 0.05 inches. And to create our model, the easiest way to approach this example would be to first create 2 rectangles like so, using these sets of coordinates. Keep in mind that I made a mistake here. This width should be written in as 7 rather than 8. So once we create these 2 rectangles, we're going to create 2 circles on the ends, which will give us our curved edges here. Next, we're going to add all these areas together, creating one solid object. And using this object, we're going to create a line fillet here in the corner. Then using this fillet line, we're going to create an area right here, and then add that area to the larger one. Our final step would be to create a circle using these coordinates right here, and with that circle subtract the area from the larger area, and that will give us our general shape. In terms of meshing, no mesh length is given to us in this question, so it is up to you guys to determine what you want your length to be. For constraints, it appears there's a 0 degree of freedom constraint here on the line, so we're going to have to specify that in ANSYS. As well, for loads, we're given a pressure load here at the top with 300 psi, so we're going to have to specify this on the top line. So we can go ahead and open up ANSYS now. And first we can start by creating our element type. So under preprocessor, element type, add, edit, delete. We are going to go ahead and create a solid model type. Make sure that 8 node is selected. Click OK. And since we specified we want a plane with thickness, under options, under the element behavior, we're going to scroll down and select on plane stress with thickness. Click OK and close that down. Next, we can enter in our material properties, which in this case are just our elastic modulus as well as our Poisson's ratio. So once again, under the structurals tab, isotropic, we are going to enter in 30 E6 psi as well as 0.27 for our Poisson's ratio. We can close that down. And now we can move on to adding our real constraints, which in this case, all we are given is thickness. So we can enter that in under real constraints, add, edit, delete, add, and we want to make sure that plane 183 is selected, and it prompts you to enter in our thickness, which will be 0.05 inches. Next, we can go ahead and create our model. So to do that, under modeling, create, areas, rectangle by 2 corners, and entering this first set of coordinates here. Alright, your screen should look something like this now. We can go ahead and create the 2 circles on the ends, as we specified earlier. So under areas, we're going to open up the circle tab, then solid circle. And using these coordinates here in the chart, we can go ahead and enter them in. Alright, your area should look something like this now. So we can go ahead and add all these together. So under the modeling tab, we are going to click on operate this time, Boolean, add, areas, and make sure that you select both circles and both rectangles. Click OK, and now we have one solid area. Next, we can go ahead and create our fillet using this solid area. So to do that, under the Create tab, we're going to select on Lines this time, Line Fillet, and we're going to select the top line right here and the inside line right here. Click OK. And next, it'll prompt you to enter in the fillet radius in this box right here. And if you look back at the question, it was given to us as 1/2 inch. So we're going to click OK. And if you notice, there's now a line that's drawn right here. So when I zoomed in, it disappeared. So if you ever want to show the line again, we can go under Plot, Lines, and that will give us the line that we just created, as well as the two inside lines right here. So to make that empty space an area now, we can go under Create, Areas, Arbitrary, and we're going to select by lines right here. So zooming in on this picture here, if we select all 3 lines that encase this region right here and click OK, that will now create an area that was encased by those 3 lines. So if we want to display the full area once again, we can go under Plot, Areas, and that'll give us our original area plus the little fillet piece that we added in later on. So we still have to add these together. Under the Operate tab, Boolean, Add Areas, and we're going to select the little area this time plus the big area. Click OK, and now we have one solid piece that has the fillet already built into it. So we can move ahead and subtract away the bolt hole that was specified earlier. So first we're going to create a circle. So under Areas, Circle, Solid Circle, and entering in these coordinates here, we should get a circle right here, and now we can go ahead and subtract this away from the larger area. Once again, Operate. This time, instead of Add, we're going to select on Subtract, Areas, and we're going to select the big area we want to subtract away from, which in this case is the L. OK, and we're going to select the area we are subtracting, which in this case is the circle. OK, and now we get the bolt hole in our plate. So we can go ahead and mesh our object now. So under the Meshing tab, Mesh Tools, we're going to set our element attributes areas. We're going to select Set, click on our area, and we are going to give it all the material properties and element type that we defined earlier on in this question. Click OK. We can go ahead and select our size controls. So under Areas, select Set, click on our area, OK. And we're going to give this a length of 0.2. But once again, this mesh length is completely up to you. I'm going to click OK. And we can go ahead and mesh our object, selecting the Mesh button here. Select our area. And now we should get something that looks like this. We can go ahead and apply our constraint now. So we can close down Preprocessor and open up the Solutions tab here in the main menu. Select on Define Loads, Apply, Structural, Displacement, on Lines. We're going to select the outside line here. And notice how once I clicked it, it locked onto our initial rectangle right here. However, we want both rectangles to be selected, or rather we want all the lines on the surface to be selected. So you may have to click again to ensure that happens. We can go ahead and click OK. And make sure all degrees of freedom is selected and our displacement is 0. Click OK. And now we have our body constraints on these lines right here. We can go ahead and apply our loads now. So close down the Displacement tab, open up Pressure on Lines, and we're going to select the top 2 lines right here, making sure this whole surface is selected. Click OK. And we know that the pressure will push inwards, so the direction is all right, so we don't have to compensate for that. But we will have to enter in the value of 300 psi right here. Click OK. And we should get arrows appearing at the top here. So we can go ahead and solve our model now. So closing down the Define Loads tab, we can click on Solve, Current LS, OK. And we can go ahead and extract the data from our model. So to do that, we're going to open up the General Postproc tab right here. Click on Plot Results, Contour Plot, Nodal Solutions, and we're going to select On Stress. And from Misses Stresses, click OK. And that'll give us our color-coded diagram of where all the stresses are with our legend here at the bottom. And if you ever want to display your body constraints, we can simply select on Body Plot Controls, Symbols, and make sure that all applied body constraints is selected. Click OK. And that'll show the constraint that we applied earlier.